Hello, learners. Hope you are keeping well. Today we are going to look at the map work again, and we're going to look at map scale. So let me get my highlighter first. We're going to look at map scale. Now I know you've done this in the junior grades, etc. All right, but it's important to remember this because it's a baseline to understanding of other calculations and the scales that you would use. Okay, so let's get going. Now, let me move my face, as I always say, before I come part of the map. All right, here we have scales. We have various scales in grade 8. You would learn the King Henry methods and whatever, converting and things like that. But I want to get specifically to the scales and we would use for our topographic maps and our orthophoto maps in South Africa when learners do their grade 12 exams, etc. You will use certain scales for your map work paper. Theory can be a bit different. They may put in a different scale to show you distance, etc. But map work, this is what you will use. So in the topographic map, all right, our learners in South Africa would use the 1 is to 50,000 scale, meaning 1 centimeter represents 50,000 centimeters on the ground. So 1 centimeter on the map represents 50,000 centimeters on the actual ground. Then we would use it for the orthophoto map in South Africa when we're writing on our exams, etc. We would use the 1 is to 10,000. See, it's disappearing. All right. 1 is to 10,000 centimeters. 1 centimeter is to 10,000, which meaning 1 centimeter on the map represents 10,000 centimeters on the actual ground. Okay, that's what we will do in when we're writing our final exams or any exams. All right, regarding our grade 12, and you find your teachers will do that for you grade 10, grade 11. You understand? And if they want to expose you for topographic maps in grade 8 and 9, if they want to put you into it, they would use these maps and scales. Okay, now we must note that maps are always smaller than the area of the ground they represent, at least in geography. Okay, it's smaller than the grounds. That is the purpose of the map. To take a big area, make it smaller, and when you do things like actual distance, etc., you can use the scale to find out what is the real distance in real life on the actual ground. Okay, it makes it easier. Imagine having a map that's the size of the place. It's ridiculous, all right? If you take a place like Johannesburg and have a map actually the size of Johannesburg, okay, that's not possible. So it's always smaller. The size by which the actual distance in the ground have been shrunk, the size by which it has been shrunk to draw proportional maps that are proportional. All right, it shrunk, but if you multiply it by the scale, you will get the actual size. All right, is known as the scale of the map. Some facts first. You understand, learners? We just don't jump into the scale. We appreciate the scale. Why it's there. That is why your teacher sometimes will make you uh, check your desk, you understand, and bring it down to a scale. And they may make you multiply uh, that size again by the scale, and you'll get the actual size using the desk. All right. So some people use the trundle wheel that clicks, and you measure the distance, and then you apply it to a scale and come draw it on a map in the class. All these strategies to make you appreciate the significance of scale. It makes things manageable. It makes things work out the distance, etc. From a small map, you can work out the actual distance. Can you see I'm very excited about this? Okay, so Let's go on. Right. Now, map scale, ways of expressing map scales. There's different ways. The first one we looked at here is a representative fraction and a ratio scale. I put it together because both are numerical ways of showing how greatly the ground distances have been reduced. It's also known as the numerical scales. Right. Now, if you look at the fraction, it's expressed as a fraction. I'm using a topographic map here. 1 over 50,000. So 1 centimeter over 50,000 centimeters. All right. Can you see it? That's how it's expressed as a fraction. Then your favorite, I'm assuming, but I know many learners like the ratio scale. All right, 1:50,000. All right, both units are the same also, so it becomes a ratio scale. All right, showing you 1:50,000. And this is what we see on the top of our topographic map. Can you see? All right, it shows on the side when they cut it for exams, it shows on the top there 1:50,000. And that is the scale of the topographic map shown there, ratio scale. And we got a ratio scale that shows us on the orthophoto map too. This is exactly how it looks. All right. So when you look at the map next time, identify it there. So that's your fraction and your ratio scale. Now, another scale that we have is a line or linear scale, a very accurate scale. All right, if I can move my face down here, besides scratching my notes. All right, now what do I notice here? It's a line across. Let's look at all these. So it's a horizontal line drawn on the map. Generally, if you find the maps the way they're designed for our exams in South Africa, this line scale is just at the bottom of the map area. You'll just find a line there at the bottom and you'll recognize this, okay, which is divided into a number of equal parts. Can you see? From there to there, it's the same distance. From there to there, it's the same distance. All right. The line scale is accurate and no calculations are used. You don't have to use calculations. All right. Because what you can do is, can you see? This line scale is in kilometers. All right. It shows you from 0 to 1 is 1 kilometer, 2 kilometer, 3 kilometer, 4. I maybe have exaggerated it here, but on the map it's accurate. Okay, so if I want to take something, I measure it with my ruler, right, or piece of paper that's not shrunk. I measure it, I bring it, and I place it on this line here to see what distance it covers. Can you see? And I can work out my distance. But sometimes you may have some little issues when it's not totally 3 or 4 kilometers. Let's look at that. All right. Now it's divided into two parts. All right. Into two actual parts. So let's look at the parts itself. Right. To the right of the zero, this is the zero, and to the right of the zero. We find each division of the scale represents a distance of 1 kilometer. All right. So from zero down here to one, that's 1 kilometer. That's another 1 kilometer, another one. But you see, it's 1 kilometer, 2, 3, 4. Then to the left of the zero, the distance represents 1 kilometer only. So from here, all right, let's look at it from there to there, it's actually 1 kilometer, which is 1,000 meters. Now, why do we have this? This is divided into 10 equal parts, each representing 100 meters. You know, if it's 1,000 meters and there's 10 equal parts, 1,000 divided by 10 is 100. So each one of these represents 100 meters. Now, why do we have to have it like this? Let's take this first one. I measured on the map and I found that the measurement ends here. So easily I could say it's 2 kilometers, right? It's 2 kilometers. Now, what happens if I take my piece of paper or my ruler? I think ruler is more preferable, all right? Ruler is more preferable. Take it and go and measure. And let's say, and there goes my slide, and there it comes back. I put it here and it ended off down here. So it's 7, all right, point something kilometers. I could take this distance that left over and bring it down here. And when I put it down here and I see, oh, it covers, so it's actually or rather, so I do apologize. I should be taking it from here. So let's go that way. I am getting old. All right. And I bring it down there. Oh, so it's 1, 2, 3, 4, 5, 6, 7, 8. So it's very, very simple, Ernest. Now, how do I do it? You say, but I have to then go to my paper and then I have to take the piece. No. When I found it down here, learners, right, my paper came from 0 to that point. All right. All I do is I move my paper. I know it's 7 point something. All right. I move my paper here, the edge of the paper here, and I bring it across. Okay. And there I find it ending here. So that is why the 0 is here and the 1,000 meters is there. So all I do is I move my paper, I come to the 7, all right, and I check. Whoa, there's the difference here. It's covering up to that point or that point. Okay, very, very important. All right, very, very important. And I want to demonstrate this again. So I'm going to remove some of these lines. I'm going to use my eraser and I'm going to remove and remove and remove and remove. Oh, I'm enjoying this. It's brilliant. All right. So I found that, and I know I do it in class also. I do this one more time. The kids look at me and say, eh? So first I found that if I put my paper, it came here. All right. Which is not good for me. So when I put my paper again, I found that it came from the 0 and it went here. So all I do is I shift my ruler or paper to the 7 because it's 7 point something and I take it across. Okay. And I take it across and I find it ends there. Oh, so it's 7.1, 2, 3, 4, 5, 6. 7.6 kilometers. I think I've drummed it into your head now. Let me stop now. Okay, let me stop regarding that. Okay, so let's go to the last scale. Okay, the last one, which is my word scale. My word scale. All right. Right. Now, what this does, it indicates the scale by means of a verbal statement or a written statement, eh? Right? Because in exams, you're not going to talk out loud. Okay? So let's change the verbal to a written statement. All right? Such as 1 centimeter on the map represents 50,000 centimeters on the ground. All right, you write it. Don't write 1:50,000. No. And sometimes I prefer that you write even the 1 as ONE, and you write the 50,000 as the FIFTY and the word 1,000 centimeters. You put everything in the word then if you want to. All right. So it's actually telling the whole thing. If you just write 1 centimeter represents 50,000, you're not going to get it correct. You have to say 1 centimeter on a map represents 50,000 centimeters on the ground. So here the scale is given in words, all right, verbal or written. Note the statement mentions two distances, eh? Don't forget. The smaller distance refers to the map, and the larger distance refers to the ground. All right? The larger distance refers to the ground. Okay, always remember that. Right, so I'm writing it again. 1 centimeter on the map represents 50,000 centimeters on the ground. Now, before I finish off for today, I want to ask you a question. If I put 1:2, and I'm going to try my writing again, and this, and I'm to put another two, three zeros, very painful for me. All right, and I'm going to put one more zero, and I'm going to write this. All right, one, and then I'm going to put a 10, and then I'm going to put three zeros. Right, I'm enjoying myself. Right, and I'm gonna ask you now, which scale is larger? Now, learners, many of you make this mistake. You understand? You say 50,000, oh, that must be larger. 10,000, a smaller number, it's smaller. Actually, let's look at it. In this scale, on the topographic map, things are brought 50,000 times smaller. And here it's 10,000 times smaller. I just want to use an example. I got an orange. I cut it into 50 pieces. All right? So I've got 50 pieces. I then take the same orange, and same size orange rather, and cut it into 10 pieces. Where will be my slices be bigger? The slices will be bigger in the 10 pieces instead of the 50 pieces. So it actually works the opposite. All right. The 10,000 is your larger scale. Okay, so it's all about visualizing and making sense. All right, learners, I hope this clarified the map scales. All the best. Goodbye.